CRC ORE developed an integrated research portfolio that spans the mining value chain. It's undertaken foundation research and supported the CRC signature technologies, grade engineering and the integrated extraction simulator. The first group of projects developed improved methods for defining the resource.
CODES is the Centre for Ore Deposit and Earth Sciences at the University of Tasmania. Our mission is to conduct impactful research for the minerals industry across the mining value chain, from exploration through mining to waste management. CODES is collaborating with CRC ORE on the geological controls on grade by size fractionation project. Our research is being conducted to identify the rock properties, textures and minerals that influence whether rocks will undergo natural size fractionation during mineral processing, with the ultimate goal of trying to be able to identify suitable materials in a mine site that can have grade engineering applied to them, and we want to be able to recognise that early during exploration drilling or during routine drilling at mine sites. So what we're looking for are tools that help us to identify where the opportunities are present, where the metals of value are contained in certain textural features or locked up within certain minerals that are going to partition or fractionate into specific size fractions during rock crushing. And so we're able to actually optimise the processing of those ores by recovering the bulk of the material from a particular size fraction. The potential outcomes of this research are enormous for society and for the minerals industry. We can reduce power consumption and water consumption by just a fraction. It has an enormous impact on the total consumption of power by the minerals industry for society. So it really is a game changer for society if we can achieve this.
The University of Adelaide's research programming is world leading. The CRC ORE project that I worked on here is developing a grade heterogeneity index in order to distinguish whether grades are homogeneously spread through a resource block or whether they're preferentially clustered. It's the first industry-based heterogeneity index, and secondly, it's the first one that's actually been trialled in an operating ore body. So it will deliver a cost-effective approach to trying to extract from an ore body those grades that are economically viable and dispensing with those that are not economically viable. It's important because it not only reduces the costs and takes out unnecessary material, but it also has an impact on reducing the environmental impact. These large CRC-type projects provide an opportunity that are not really available in standard research-funded projects, which are focused on one specific component of it. So in our aspect of this research, we can see where this fits within an integrated approach to optimising, framing specific problems that are identified by industry. This was a fundamental aspect of improving mining operations, both economically and environmentally.
We're dedicated in the CSIRO to solve really challenging sensing problems in the mining industry. We've been collaborating with the CRC ORE on a number of really innovative projects where we're trying to develop really novel sensing technologies. Our bench project involves sensing ore grade on the mine bench, and currently that's a difficult process to undertake accurately, and what we're trying to do is short circuit some of those issues with a brand new technology that scans over the bench prior to drilling and blasting. The technology will be one of the levers that's really trying to improve the sustainability of mining, in that we can actually deliver more metal for the same environmental footprint. It is really groundbreaking technology, and that's thanks to the collaboration that's been provided with working with CRC ORE.
Having defined the resource, we then develop new techniques for blast design and modelling of ore transport.
Mining 3 is a membership-based collaborative organisation, and our objective is to develop innovations that drive safety, productivity and sustainability for the future of the mining industry. So Mining 3 and CRC ORE are both working on concepts that look at improving the accuracy and precision of how we mine. We particularly look at how do we reduce the amount of waste or material that doesn't have any value from going through process streams, which reduces the amount of energy we use, the amount of tailings we create, the size of the holes we put in the ground, and the engagement in the environment. And that it has a big impact on the sustainability of the mining industry.
I've been working on 8 different projects for CRC ORE, from right across the value chain, from linking the geology into mining and from the mining into processing. We wanted to link the sensors that measure the geological and geotechnical information to enable us to develop much improved blast designs. Then the second projects were custom blast designs, to take that information and to be able to develop blast designs automatically using the Mining 3 custom blast design tools. We were able to change those so that they can identify the best blast design for a whole level in a mine. We've also realized that in many of these grade engineering rock masses that the ore is soft and the waste is hard. So we did a lot of work to develop blast designs that can break the soft ore and leave the hard waste, and so that you can sieve or sort those materials much more easily, and then it means that there's much less processing and energy required to process the ore once the waste is separated.
My projects that we've been working on are focused on modelling for grade engineering solutions. Challenges, of course, for mining is that when a technology or solution comes along that introduces a change to the mining process. So what we've done is develop models and methods to look at how we can simulate the mining process to better understand the impact of those changes to the mining operation. The value in modelling, it allows you to reduce the risk and getting it right at the start of the operation. CRC ORE has been fantastic for giving us access to several sites of data, so we can look at the variance in operations and how mines operate today.
The CRC ORE projects will have a significant benefit to existing mines within Australia, but also to those next generation mines, so the way we design and implement and create mines in the future.
Following on from these innovative blast designs, we needed to understand how we could fragment the rock differently to enhance the response from grade engineering.
CRC ORE has funded a number of projects at the University of Queensland, and I have a privilege to be involved in several of them. The Enhanced Grade Engineering project was focused on improving ore amenability to the grade engineering approach. The problem we were trying to solve is, can we improve the metal deportment into fines by combining different modes of breakage? The CRC ORE team has shown that the grade engineering approach is applicable to some ore types, but for others won't work. This project has demonstrated that enhanced grade engineering concept will work on those ore types that wouldn't be amenable for the traditional grade engineering. We demonstrated on a lab scale that it is possible to change metal deportments into fines by using more precise and more controlled breakage energy, and that would increase the number of ore types that are amenable to grade engineering. The collaboration between CRC ORE and University of Queensland unlocked a lot of research that will bring a huge impact to the industry.
At Curtin University, the focus has very much been about gold processing and how we can utilize these resources a little bit smarter. The main project that we've worked on with CRC ORE is how we might apply a density-based separation to material coming out of your mill and going into your processing circuit to try to remove gangue material. The benefit to the mining industry from the CRC ORE gang rejection project in the Myra P420 project is we can unlock ore bodies that were previously uneconomic, and we can mine them smarter. Less energy, less reagents, less tailings, coarser tailings, safer tailings impoundment, and those sorts of things will have an impact not only on the mining industry, but the communities and the environment that surrounds them. The outcomes from CRC ORE will be continued to be used by the people who were involved. They're setting up a lot of ways to support transitioning these outcomes into practice in industry. This will just continue into the future as a legacy of CRC ORE.
For real-time sensing and sorting of crushed ore, the CRC supported development of 3 new and novel sensing technologies. This is a remarkable achievement within 6 years.
The National Research Council of Canada, or NRC, is Canada's largest federal research and development organization. The NRC, in partnership with CRC ORE, has developed a new sensor technology for the mining industry based on laser-induced breakdown spectroscopy. The sensor technology aims to understand the mineralogical characteristic of process stream in order to optimize the processing strategy. The ore value not only depend on the grade, but also on the mineral in which an element is embedded, as well as the other mineral surrounding. Our technology allows to do real-time online mineral quantification. The benefit of this technology is to get a quantitative mineral distribution of the ore online in real time to make a decision relative to the ore value.
The project is to explore novel fluorescence, as we call it, to create real-time techniques for identifying minerals in mining and mineral processing. Nobody anywhere has been applying in virtually any field. It's very much a whole new breakthrough into new applications. The overall benefit of this is the ability to eliminate the contaminant mineral, allows the mine to actually operate. Other cases, yes, it will reduce water use, electricity use, plant wear, the lot. It's multiple benefits at different stages of different mines. CRC ORE enabled the creation of the entire program. The discovery rig we've built in the Braggs building is unique globally. There was no precedent to copy. We've bought and connected up and designed a lot of new high-tech pieces to create a novel facility. And that was really only possible in an entity of the scale of a CRC with the long time frame involved. It's the best team I've ever worked with, and it's motivated by the excitement of discovering new signals, new things every day basically, that have got so many different directions. We're literally looking at everything from outer space to paleontology to mining to medicine. So it's absolutely staggering what this technology can potentially bring.
What we're trying to do is to measure how much gold there is on a conveyor belt. The reason we're trying to do it is that in bulk mining, where we have very low head grades, trying to improve the production efficiency by throwing out waste that's going to processing and retaining some more material out of what was a waste stream that's actually good. And hopefully we could end up, even in some applications, processing half as much material, so half as much grinding, half as much chemicals, half as much water, for nearly the same amount of gold. That's the end goal. From the industry point of view, we hope we can massively improve the efficiency of certain gold mines, which is very important for the environmental impact. Without CRC ORE, we would have had a very hard time raising the industry interest. So we certainly wouldn't have got as far as we've got in the last few years. And we certainly wouldn't have a network of people eager for uptake or implementation.
Development of the Integrated Extraction Simulator provides insight, prediction of impact and risk across the value chain.
The collaboration between CRC ORE and MREWA was fundamental to grade engineering and IES, firstly through the grade by size deportment trials, and then actually carrying that through to scaling those tests up to higher technology readiness levels. IES was absolutely fundamental in terms of breaking down the siloed approach that business typically has to grade engineering type problems. The unique thing here about IES is that it allows us to locally optimize by incorporating a whole range of models, and you actually tend to look at your operation from a systems perspective. We see a unique opportunity for the grade by size deportment and online assay as enablers to actually extend the life of these operations and drive productivity gains through reduction in operating costs and accessing previously marginal ore.
P9Q is a mineral processing optimization program, and each iteration has advanced mineral processing, particularly bringing together the physics and the models around those in a very applied and practical sense. Working with CRC has been a great opportunity to bring all of those models together onto the IES platform, and that has been quite a useful applied integration of the technology. But IES offers a future where we can integrate knowledge from across various research programs, and I see an opportunity there for educating and developing the capability of the mineral sector. Myrick Global have really enjoyed a close relationship with CRC ORE in progressing not only the P9 project but its integration into the IES program. This has allowed 60 years of research to really come together to deliver an integrated solution.
So the SMI is quite a large group, and really our focus is trying to identify and solve the problems around future mineral supply and the mining industry and its context in the world. The JKMRC's been very involved in a number of important projects within CRC ORE. The Integrated Extraction Simulator, that's gone on, of course, to be one of the flagship products associated with CRC ORE. Really what makes the Integrated Extraction Simulator and our work on that project unique is that CRC ORE has provided a backbone that allows for incorporation of the best possible and most recent possible versions of those various different machine simulations in a way that can be used effectively by industry. The incorporation of better machine models into the Integrated Extraction Simulator essentially allows companies to be more efficient and to be better at testing different alternatives for processing in a way that will allow them to produce more metal for lower cost and to produce fewer environmental impacts in the course of doing that.
These technologies have no value until they are successfully integrated into the mining value chain. So to balance the research portfolio, we also examined the barriers to technology uptake.
QUT is interested in solving real-world problems, and so it undertakes research which really deals with the real world. Through partnering with CRC ORE, we've developed deep knowledge of the mining industry. That has allowed us to produce a suite of management tools to assist mine managers in the adoption of technologies into mining, the risk management processes around introducing new technology into mines, and also the management of social license around mining. Understanding those complex systems is challenging, and working out ways of dealing with them and managing them is the real challenge. Because of CRC ORE, the mining industry now has access to pre-concentration and simulation technologies. Importantly, with our research, the industry also has the tools to increase the uptake and deployment of those technologies. The highlight of working with CRC ORE is the deep connections we develop with industry. The collaboration for the development of problems is excellent.
CRC ORE was fortunate to work with a group of world-leading research institutions. We really couldn't have achieved these valuable outcomes for the industry and society without their commitment and contributions.
CRC ORE has really provided an important path for us to develop our technology from a low readiness level to something where people can really see the benefits of an advanced prototype.
CRC ORE is one of the institutions which managed to put researchers and industry partners together at the same table.
Things evolve, you have multiple phases, you get a result, you move to where that result leads you. And you've got the flexibility within a CRC to do that.
With the CRC, it's taken it from basically just an idea to something that we really think we can commercially push for in a credible fashion.
The CRC ORE paves the way for the future of the mining industry in terms of framing specific problems that are identified by industry, rather than blue sky research in which we address a problem which might not ever find some implementation in industry.